of kx, if you'll, I mean, this is a generalization of the dot product. You're picking off the coefficient of f of x in the sine kx direction is what this is. That's a way to understand what we're doing. I do want to show you the details here. Come on. Come back to us. You can do it. Thank you. Now, the letters have changed, but the spirit of the argument remains the same. I don't have all the, I mean, you know, basically I get to the point, oh, so my general solution looks like this, right? I've showed you in pretty good detail how we get to that, right? I'm using b sub n for the sort of undetermined coefficients, if you will, of that problem. And so I say, well, what we want to do is write 1 minus cosine 2x as this infinite sum of sines. And to do that, all I have to do is find the Fourier expansion of this 1 minus cosine 2x. So long story short here, so I say recall the Fourier sine series for 0 to pi. I just worked it out for you, the kernel of it. I mean the nub of it, which is just that you integrate your function with respect to sine from 0 to pi and multiply by 2 over pi to get that coefficient. So basically, I have the details on practice homework page 134. And what it works out to is that only when n is odd is this integral non-trivial. You can work out that when n is even, the integration works out to 0. When it's odd, the integration works out to this. So that's your b sub odd coefficient, just like that. And so when I look at the formal solution, all of the even coefficients are 0. And I just use odd coefficients where the weight is given by this thing right here. So there it is down here as the solution. Sum k equals 1 to infinity 2 over pi, 2k minus 1 minus that plus that times sine of that. This is the solution, the complete solution to the heat equation for that given initial condition. Yeah. This one's a little bit easier. Or is it? Oh, this one's weird. This is that mixed thing. I don't even want to look at this. It's hideous. Curses. Let's see here. It might be useful for me to... Where was it? So in this table on your web page, right? You guys should notice down here I have heat equation, wave equation, Laplace equation, and here there's practice homework, such and so forth. Like in here is some solutions to heat equations, and this looks more like what we did today, right? I'll get to it eventually here. This one's a little bit different, isn't it? Oh yeah, see, this one's got the insulated boundary conditions, right? So insulated boundary conditions makes you look at a sum of cosines for your solutions. And so then you have to use the Fourier cosine series to fit the initial condition, right? Let's see here. All right. Well, anyway, I hope I have told you enough today that you can start to see how to do it. Have you guys ever seen the Fourier series before? Not really? So I also cover a little bit of this in linear algebra, or applied linear algebra. And if I can, come on, it's not playing nicely with me today. All right, here it is. So here's just a plain old. I mean, we can talk about Fourier expansions independent of the partial differential equation. Like partial differential equation leads us to Fourier expansions of functions, but you can think about a Fourier expansion of a function independent of a particular differential equation, right? I mean, they just happen to go hand in hand in the solution technique as I just showed you. But if you want to define the Fourier expansion of this thing, which is the what? This is like the square wave. It's going -1 and then 1. So it's like this and then that. So it's just basically a switching function. And then suppose it repeats over and over and over again periodically. You can calculate the so-called the Fourier expansion of this, of the square wave. And so I worked that out here by doing these. This is actually the inner product. I'm studying inner products in linear algebra. And the inner product of that is just this integral. And that is just this integral. But it works out as it happens to 4 for the constant term, and for a minute 4 for sine, and then either 0 if k is even or 4 over k if k is odd. So basically, we get this Fourier expansion of the square wave. It's 4 over pi sine of t plus 1/3 sine of 3t plus plus plus. Oh no, plus plus. That's not good. 1/5 sine of 5t. And so forth. In general, here's the Fourier expansion of the square wave, and here's a picture of it. So you can actually see in here, here's the first, like the 0th order term, here's just the sine, which is kind of like the square wave, right? But then when you take the sine plus the 3rd order term, it starts to look a lot like it. You know, here's the 3rd order plus the sine, it's just that term. By the time you get to the 5th order contribution, it's getting pretty close, right? And as you add more and more and more and more and more modes, more and more frequencies, you get closer and closer and closer approximations to the square wave. This is Fourier analysis. This is also what MP3s are based on. So like your MP3 files, they're based on something like taking sound and decomposing it into its frequencies, and then you record the frequencies as the sort of the spectrum of the sound. And that's what Fourier analysis is about. It's saying, I mean, what these integrals are doing, if you integrate the function with respect to sine of kt, that's picking off sort of that frequency. K is the angular, like kt, what is that? That's, yeah, kt has to do with angular frequency k, right? So it's picking off that frequency component of the waveform. And so, of course, if you guys study communications, you probably spend a few weeks, I would guess, talking about Fourier analysis. And you probably know more about it than I do. All likelihood after that, which would be great, since I don't want to be pompous. But anyway. Okay, so guys, I was hoping to do something today with you guys. If you just give me just a second here. I want to talk about something with you. Real brief. Promise. So today I had planned to bring you milk and cookies. And sadly, which of course has nothing to do with the impending course evaluations. Just, you know, out of the goodness of my heart and my shared love of cookies with students. I was going to do that, and I also happen to write this course evaluation form, which I will do. We'll do this next class. I will put the milk in the fridge. I will save some cookies for you guys. It will come back Thursday, all right, and then you will fill out this glorious in-course course evaluation. I will just tell you my favorite one. I'm very proud. What I do is I give you the standard one, the standard things, and some clarifying comments, because I think sometimes these questions are misunderstood. So like, I'm particularly proud of my my modifications, for example, of number 11. I would recommend this course to your friend. Assume your friend has similar life goals. This question is not asking you if someone from a non-technical major should take this course. Because I think when you guys answer this question so many times, you think about the people you're in your dorms and you think, no, they should not take this course. Or the people you happen to share an apartment with off campus, whatever. I mean, and you're right, they shouldn't. If you're not an engineering major or a math major, probably you shouldn't be taking this course. Is the amount of time required reasonable in this course? I hope so. I mean, the question is, should it be the same amount of time as you spend on some other course that's a gen ed requirement? I mean, I would hope not. I hope this course requires more of you than that. You know, just saying. Now, this is what I'm most proud of, though. I'm most proud of this one. The course, number 17, the course integrated the subject with biblical principles. That's what the question is. So here's my comment here. Notice that all truth is God's truth. To answer negatively here would be to say that math is not a part of God's truth. Do you really want to say that? Strangest thing, my biblical worldview score went way up last semester after I did this. I don't know why. It's the weirdest thing. But then more importantly here, actually, joking aside, you know, I actually give you a chance to write down as a human, to me, another human, what you like or didn't like about the course with a pen or pencil, as long as you want on the paper, right? As opposed to this online thing, which is always cutting you guys off mid-sentence. Like, I really like the material on bleh. Thanks. It's just, there's like a 50 character limit in the, you know, anyway. So I'll let you guys do this next time. I'll shut it now. Go about your business. I will save the cookies for you. Not all of them. I mean, applied linear is going to put a hurting on my cookies, but
What?
applied linear is going to put a hurting on the cookies, but there's only like 16 of them. They can't eat that many.
Yeah, it says like half of them dropped it,
I have a cat question.
A what question?
Cat question.
Like causing harm to cats? Or, yeah.
How do you make a cat go woof?
How do you make a cat go woof? I don't know.
Soak it in gasoline and set it on fire.
That's amazing.